Hi, I'm Bill Malik. Today I'm going to be presenting a joint solution from EnterpriseWeb and Snowflake, which enables telco-grade agentic AI and multi-domain autonomous networking. This is the last in a series of 4 videos. In the previous sessions, I went through creating a zero-copy no-code integration between EnterpriseWeb and Snowflake in a matter of seconds. We were able to use that to expose an MCP interface that basically created an ODA service inventory an agent could use to talk about and reason about with the data that was actually inside the AI Data Cloud. Then you saw in a couple of minutes me create a series of land graph agents, a couple of domain-specific ones, and a coordination agent that would allow us to talk to the network. In the last session, I actually used that agent. I did the process of talking to the network to query network health, create a new service, deploy it, and even trigger some AIOps with a simulated denial of service attack so that you could get an idea of how the agent actually interacted with the platform. Now what I'm going to do is dig deeper into what's behind the AIOps use cases, how we're able to use things like Snowflake's embedded KG to help us with the continuous optimization. And at the end, I will even show you how we're able to use semantic views that we generated and pushed into the Cortex Analyst to make queries about the performance of the agent, ask questions like how efficient was the agent's capabilities and so on. Okay, so in the previous demos, you saw me create a connection to the Snowflake AI Data Cloud. Then you saw me use EnterpriseWeb to produce a set of multi-domain agents. And then you saw me use the agents to actually talk to the network and deploy and manage a new service. Now we're going to go a little bit deeper into the AIOps themselves and drill in to see what's going on behind the scenes. So we already noticed one example of how the system basically used RCA. It relayed to ServiceNow when we had a new ticket that there was already an issue that was resolved. It helped us coordinate that and basically push a high-level result over to ServiceNow, but that's kind of retrospective. What's going on though is that there is still a high level of traffic being pushed to this service. You can see the latency here is changing a little bit here, but that denial of service attack or the simulated high volume of traffic didn't stop. And what's happening though is that the system, since we activated the AIOps, is actually going ahead and continuously optimizing the service. You can see a couple of things. Again, just to finish our sort of tour of the agent itself, if we look at its trace, we'll see that at a certain point, when we actually authorize the fix, what it did, right? The system, that service manager module pushing out an alert, pushing the RCA to us and helping us make a decision. But from there, what we did was we handed off to completely autonomous networking, right? So there's no human in the loop right now doing the optimization. So pop into EnterpriseWeb and we'll see here that there are a bunch of events here that are streaming in, both predicted and detected, that are keeping this service, again, optimized. You can see the impacts of each one of those micro operations, whether they're on latency or power. Now at any time we can drill into the details of any of these operations and see at a low level, basically the RCA and then the remediation that were automated for this micro transaction. I won't go into tremendous detail, but you can see that we're actually using Graph Data Cloud function for clustering, so an advanced, probabilistic clustering algorithm that we extended out into LPG and Snowflake to basically tell us things like the fact that this service change was going to have no downstream impacts. And we then did other things like detection algorithms and so on. And eventually we came to a conclusion that the remediation in this case was to scale in one of the elements, capturing and calculating what the config changes were, right down to verifying again through that clustering that there were no impacts. Right? So what we get is a full story and full detail of every one of these operations for as long as they're running, again, for the service. So there's one other way to look at this. If we jump back into the Snowflake Data Cloud, what we'll find actually is that in addition to what we had done earlier, which was enrich the actual data and relationships and objects that were in Snowflake, what we did was we actually pushed in and generated a semantic view. You'll notice there were a number of tables here that were inserted. This is going to push in the dimensional semantics, or really like the metrics and sort of observability key points related to the agent and its operations. Right? So we're able to actually query them right from Snowflake itself. This includes generating a set of semantic views that use those tables, right? So we can see our agent impact view. It was just created. If we pop into it, we'll see, of course, the descriptions of all the sides of all the tables and so on. Again, they're logical descriptions along with semantics so that Snowflake's Cortex can exploit them. And what's nice here is this was not built manually in any way, right? This is generated completely by the ontology and by those kinds of choices that we made for what the agent was going to be capable of. You can see this at play if we go into the actual Cortex interface here and we ask questions like, what is the average impact of each operation performed by the agent? What we get here is actually beyond sort of the normal generation is we get text to SQL in place, right? Again, mediated by our ontology. So if you go down far enough here, you'll see it, right? So again, this is going to be correct. This is generated based on what our ontology pushed into Snowflake, all of its descriptions and so on. And then we even get the interpretation, right? It ran those operations and gives us the responses that we want here. So again, showing that the AIOps are sort of inspectable from almost any angle that you might want from the lowest level of detail, supported by SQL and Cortex agents in Snowflake, or the interfaces the agent exposes to LangGraph, or simply straight up in Enterprise. That concludes our series of demos showing a joint solution between EnterpriseWeb and Snowflake for telco-grade agentic AI. Across the series, you saw me start by creating a zero-copy, no-code integration between EnterpriseWeb and Snowflake in a matter of seconds, and our ability to expose an ODA service inventory to agents at large in a controlled, secure way. You then saw me in a matter of minutes create LangGraph agents that were going to utilize the power of the combined solution for end-to-end multi-domain orchestration across a set of domain-specific agents. Then I used those agents to have a natural language interaction using Cortex to let me talk to the network. I queried network and service health, I ordered a new service, and we even simulated an attack on the service to show you how the system would react, how service assurance and optimization kick in. And in this last session, we drove into the AIOps behind the system. We saw autonomous networking. We even saw the ability to look at something like a semantic view via Cortex to actually analyze the impact of our agent. Thank you very much. I hope this gave you a good idea of telco-grade agentic AI provided by EnterpriseWeb and Snowflake.